Hi friends, and welcome to an interesting physics class. Today we're going to be answering this question on projectile motion that says a shot is fired from a gun on the top of a hill 90 meters high, 90 meters. So the distance, okay, from the ground to the top is 90 meters, which is the height. And then it also says that with the velocity of 80 meters per second at an angle of 30 degrees with the horizontal. Find its horizontal distance from the point of projection when it hits the ground. All right, what do we do at this very point? We need to understand that this velocity here, as long as it was launched at an angle, has components in the x and y direction. But let's write it down here. We have our 80 meters per second, and the angle is 30 degrees. They're asking us to find the horizontal distance from the point of projection to the plane of impact. This right here is the plane of impact. They're asking us how far will the projectile that was launched on the hill go. So it's actually how far. So basically, they're asking us for the range of the projectile. How do we do this? Before we begin, I want you to understand certain things about projectile motion. You see, the time of flight is dependent only on the y component of the initial velocity. This 80 meters per second here is just the magnitude of the velocity. It has components in the y and it also has components in the x. So to find the time, why is time important? Because the formula for the range is simply range is equal to v naught x multiplied by time, right? So this formula was gotten from this x is equal to v naught x t, okay? Then we have plus or minus half gt squared. But if you look at this case here, there is no acceleration due to gravity in the x direction, in the sense that gravity only acts downwards. It does not act horizontally, right? Gravity does not act sideways to the left or to the right. No, it only pulls things down to the center of the earth. And in this case, since we're talking about horizontal distance right now, because when you talk about how far, the range only talks about how far it covers or it goes in the x direction. Now, if you look at this right here, you discover that there is no gravity or there is no gravitational force in the x direction. This means that if you replace the g with 0, we have that x is equal to v naught xt plus or minus. So if you look at this right here, we have half, we put a 0 here, t squared. What happens is that everything here will go away because 0 multiplied by t will give you a 0. 0 multiplied by plus or minus half will also give you a 0. And you'll be left with x is equal to v naught x multiplied by time. Why? Because there is no acceleration due to gravity in the x direction. So the formula for the range now simplifies to this. So what do we do at this very point? Since it was launched at an angle, we have to go ahead and break the velocity into its x and y components. Let's do that very quickly. So right here, I'm going to write my solution. Remember I said that the x component is very simple, right? But the y component is kind of complicated because the time depends on the y component. The time is going to take to go from the point of projection or to the plane of impact depends only on the y component of the initial velocity. Don't use this 80 as it is. No, don't use 80 as it is. Break this 80 meters per second down into y and x components. Use the y to find time. Use the x to find the range. That is how it works. Now, how do you break this velocity into components? We say that The initial velocity in the y direction is equal to the initial velocity multiplied by the sine of the angle. And the initial velocity in the x direction is equal to the magnitude of the initial velocity multiplied by the cosine of the angle. In other words, these are very important formulas that you need to know when it comes to breaking velocities into their respective components. Right here, we have that the initial velocity in the y. This means v naught y, okay? V naught y means initial velocity in the y direction is equal to v naught sine theta. And the initial velocity in the x direction is v naught cos theta. So let's quickly do that. Let's break it down. Right here we have our v naught y is equal to, what is our initial velocity? That is the magnitude. Our v naught is 80 sine 30. So 80 sine 30, what do we get? Let me use my calculator. So right here we have 80 sine 30. It gives me 40 meters per second. So 40 meters per second is basically the initial velocity in the y direction. Why are we doing this? We know that velocity is a vector. And we know that when you have a vector that is actually inclined at an angle, in this case, let's suppose that we have this very vector here, inclined at an angle of 30 degrees. And the magnitude is, let's say, 10. We have to get the components for the y and for the x, right? So that's also what we're doing right here. To get the component, this is the y. So we use the sine for the y, and we use a cos for the x. And that's also what we're doing right here. So for the y component, we are breaking it up because the time taken depends only on the y component, and the range depends on the x component, right, of the initial velocity. So now we say that our v naught y is equal to 40 meters per second. Now we're done with this. How about our initial velocity in the x direction? How do we get that? To get the initial velocity in the x direction, we say v naught x is equal to v naught, okay, cos theta. Let me plug in values. We have v naught x is equal to, what is our initial velocity? We have it as 80 cos of 30. Let me use my calculator again. So 80 cos 30, this is giving me 69.3. So this is equal to 69.3 meters per second. Therefore, we have our v naught x to be equal to 69.3 meters per second. All right. So if you look at this right now, we have actually broken this velocity into two. For the x component, we have that the initial velocity in the x component is 69.3 meters per second, while the y component is 40 meters per second. This is just the magnitude, right? Now, what do we now do with this 40 meters per second? How do we work it out? Or what do we do with it? This is what we use to find our time, because the time taken, like I said, depends only on the x component of the initial velocity. That was what I said, and that is how it works. Now, I would want you to use the quadratic formula to find the time in this very case, because it is the most accurate in this very case. So apparently, you're going to use this 90 meters, this height here, to find, to create an equation, or to create an equation which you can solve using the quadratic formula to find your time. Yes, so that's how to do it. Let's do that very quickly. Remember that the height, I would say, the final height is equal to 90 meters. So what was our initial height? Our initial height was 0 meters. Look at this here. So from the foot of the hill, this is 0, okay? This is 0 from here up to 90. Okay, so right here, okay, this is where it ends. So this is 90 meters. But down here is 0. Why am I doing this? Because people get a lot of make a lot of mistakes when it comes to creating the quadratic equation with which they can find time. Look at where the error lies. So the formula here is from the second equation of motion, we have that y is equal to v naught t plus or minus half gt squared, something like this, right? So in this very case here, people make a lot of mistakes at this very moment. Why? Because they just substitute the 90 here. They just put the 90. They say 90 is equal to what's the initial velocity in the y? They say 40 t. Then they say minus half 9.8 t squared. Then they move the 90 across and they end up making a very terrible mistake, which will give them a wrong answer, right? So this one right now is not acceptable. This is not acceptable. Why? Because you have two heights here. Whenever you're dealing with a projectile launched from a height, you have to consider the initial and the final height. It is a must to be able to create a perfect equation with which you can solve for your time. But if you don't consider the initial and the final height, then you'll be in trouble. You must make sure that you consider the initial, okay, which is 90, and the final, which is 0, because it's actually going to start from 90, right? So it's going to start from 90, and it will go all the way and land down here, which is 0 meters. So it's going to start from 90. 90 is the initial, and it's going to land here to the final. And you need to understand that this very formula here, which is y is equal to v naught yt plus or minus half gt squared, this is actually displacement. And we know that displacement is given as final minus initial. So that means that you're going to open this up. You're going to break this into two. And we now say y final minus y initial is equal to v naught yt minus, why are we using minus? Because it's going upwards, half gt squared. And let's continue with our solution. We say, what is our final height? Our final height is 0, because it's going to land on the ground, minus, what was our initial height? Our initial height was 90, as we've seen right here. Like I say, I'm going to repeat. This is 90 meters, okay? This 90 meters, then it's going to go upwards and fall on the ground. So right here is 0 meters. So we say 0 minus 90, okay? So our final is 90, our final is 0, our initial is 90, is equal to, we now ask ourselves, what is the y component of the initial velocity? We got it as 40. 40 multiplied by t minus half, what is our g? We're not giving, but we can use 9.8. So multiply by 9.8 t all squared. Let's clean this up. We have 0 minus 90 will give you negative 90 is equal to 40t minus half of 9.8 will give you 4.9 t squared. So to create a perfect quadratic equation, I'm going to move the negative 90 across. We now have 0 is equal to, if the negative 90 goes across, it becomes a plus. We have 90 plus 40t minus 4.9 t squared. So let me flip this equation. We now have, if I flip it, we're going to have negative 4.9 t squared plus 40t plus 90 is equal to 0. So this is the quadratic equation that we need. And with this, we can solve for the time. Remember that the t in this equation represents time. Represents time. So if you can solve this quadratic equation right here, we can find the time it takes to go from this point of projection to the plane of impact. And when we find that time, we simply plug it into the range formula. We put it in here. We put it here. multiply it by the initial velocity in the x direction, and then we can get the horizontal distance, which is the range. Okay, that's how to do it. All right, let's continue with our solution. So now we've created a quadratic equation. Let's now identify our values. So here we have our a. If you compare this with ax squared plus bx plus c is equal to 0, which is the general form of every quadratic equation, we'll discover that our a is equal to the number in front of the t squared, which is negative 4.9. Our b is equal to the number in front of the t, okay, which is 40. And our c is a constant term, which is 90. So we can now, it also depends on how you want to do it out, how you want to work it. You can choose to multiply everything here by -1 to remove this negative sign here. That is if you want to complete the square. But if you want to use the quadratic formula, it's just okay. So let's continue. Here we have t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We can plug in and solve right now. So what do we have? We've got our t here is equal to, let's plug in our values. Our b, as we have here, is 40. So we have negative 40 plus or minus the square root. Our b again is 40. So wherever we see b, we put a 40. In this case, we have 40 all squared minus 4 multiplied by our a. What's our a? Our a is negative 4.9. And then our c is 90 all over 2a. 2 multiplied by our a. Our a is negative 4.9. Okay, remember, what are we solving for here? We're solving for our time. We say our t is equal to negative 40 plus or minus. I'm going to draw this again. So 40 squared is going to give you 1600. Let me confirm that. Yeah, so 40 squared will give you 1600. Now here you have negative 4 times negative. So this negative here multiplies the negative here. We now have negative 4. Let me point it on my calculator. Multiplied by negative 4.9. Multiplied again by 90. What do we have? We have plus 1764 all over negative 9.8, because 2 times negative 4.9 will give you negative 9.8. Let's add these two terms together, this and this together. Here, right here, we have 1600 plus 1764. What do we get? We get 3364. So we have that t is equal to negative 40. Okay, let me do it down here. So our t is equal to negative 40 plus or minus the square root of 3364 all over negative 9.8. Okay, so what's the square root of 3364? The square root of 3364 is 58. So we now have that t is equal to negative 40 plus or minus 58 all over negative 9.8. So this plus or minus here indicates two solutions. It indicates two solutions. So we are going to split this into two. So we say t is equal to negative 40 minus 58 all over negative 9.8, or t is equal to negative 40 plus 58 all over negative 9.8. So the plus or minus here indicates two solutions. One will be a plus, one will be a minus. This is a minus, and this is a plus. So let's check it out. We have that our t is equal to negative 40, negative 58 will give you a negative 98 over negative 9.8. So this gives you the negatives, they cancel out. 98 divided by 9.8 will give you 10. And since we're looking for t is measured in seconds. So this gives us 10 seconds. And for this one right here, we have negative 40 plus 58 will give us that t is equal to negative 40 plus 58 would give us 18 all over negative 9.8. But this very value will give us a negative answer, and t can never be negative. Time can never be negative. It is impossible for time to be negative. Therefore, we discard this solution. Whenever you're solving using the quadratic formula and you discover that your time is negative, it means that you're wrong, or you can actually ignore the negative answer and pick the positive one, just like we have here. So it means that it took 10 seconds for this projectile to travel from this point here of projection down here. So now, like I said, we have found our time. We have our initial velocity in the x direction. We can now solve for the range. Now let's do that. So what was our initial velocity in the x direction? We got this value here, 69.3 meters per second. So we now say the range is equal to v naught xt. Remember I said that this v naught x here means the initial velocity in the x direction, and the time here means the total time it took to travel from the point of projection to the plane of impact. We can now plug in our values and solve. We say that r, which is the range, is equal to our v naught x is 69.3 multiplied by 10 seconds. So our range is going to give us 69.3 multiplied by 10 will give us 693 meters. And this is our solution. So this means that this projectile traveled 693, okay, meters. So from here to here is actually 693 meters. And this is our solution. So you've seen how I did this. We went all the way from here. We solved for the time. Like I said, since the time is dependent on the y component only, I'm going to write it again. The time taken is only dependent on the y component of the initial velocity. You must always remember this. Do not forget it. The time taken to travel from the point of projection to the plane of impact is only dependent on the y component of the initial velocity. Don't miss that, which means that you always have to find the y component of the initial velocity, and with that, you can solve for whatever you're looking for. So it is also safe, whenever you're given a height, it's also safe to use the quadratic formula because it gives you the accurate time. If you break it into chunks, you might lose, okay? You might not be able to round it up appropriately or properly, and that is why I always advise whenever you're given a height, like in this case, we're given a height, always make sure that you use the quadratic formula by always remembering, and also remember that here, we don't just say y is equal to, we break it up, we say y final minus y initial. Okay, it's really very important. Don't forget this. And you can now substitute your values and solve for t. With that, you can get whatever you're looking for. So thank you for watching, and see you some other time.